Hi friends, welcome to UGC NET online pre-coaching. Sorry all my subscribers and viewers, last 1 month I have not possible to update videos due to change in my job location. I have faced some problems. Sorry all my viewers. Every day so many of you mailed and requested to update next videos, so I have tried many times but not possible. Next it will not happen. Definitely I will update next videos in soon. Once again thanks to all who are waiting for my videos. Today I will start with June 2006 and I'll discuss first question. Which of the following string is in the language defined by the grammar? Actually they have given two languages, means S of 0A and A of 1A or 0A or 1. Here S and A are the non-terminals and 0 and 1 are the terminals. So I hope you know the basics of finite automata and theory of computation. Actually the given problem is which of the following string in the language defined by the given two languages, find in these three outputs which is satisfied for this language. Okay, to solve this type of question, just start with the initial symbol. The given is S is equal to 0A, so A is equal to 1A or 0A or 1. So substitute A is equal to, there are three options, 1A, 0A and 1, but if you substitute 1 it is terminate, but there is no output here, so don't consider 1 here. Now you substitute 1A or 0A. For looking your first iteration only, you can assume means your answer starts with 0, because this initial state starts with 0. Definitely your answer should be starts with 0. Okay, and A is repeatedly it is generating, so definitely if it A is ends with terminal, that is 1. So for looking this language only, you can assume this is starts with 0, ends with 1, so answer is B only. That is initial assumption. So check it how exactly, but we will solve step by step. 0 A is, I will substitute 0 A. Now what is your A? Again A I will substitute 1A. So what is your A? 1A. So now we got 0 0 1A. What is your A? Again I will substitute according to B, that is 0 0A. Okay, then what is your A finally? That is 1. So you got 0 0 1 0 1. It is easy way to prove this one. I hope it's very easy. Just it's work like a iterative functions, recursive function. It is just go on substituting itself, A substituting itself, here also A substituting, here also A substituting. So so answer is B. Definitely you will get so many questions like this, so please, it's a very important subject, theory of computation and finite automata, and just go through it some basics, and we'll go for second question. For a complete graph with n vertices, the total number of spanning trees is given by. It's a standard, it's a straightforward question. If you know the answer, you can answer directly, but before that, before answering this one, I will explain what is complete graph and what is spanning tree, then we will go for the answer. Okay, what is complete graph? Complete graph means all the vertices has edges with remaining all other vertices, means every vertex is connected with individually all other vertices. That is directed graph, means complete graph. A complete graph is a simple undirected graph in which every pair of distinct vertices is connected by a unique edge. It should connect with the unique edge with all other vertices. A complete digraph means if it is a directed graph. A directed graph also may have a complete graph. Is a directed graph in which every pair of distinct vertices is connected by a pair of unique edge. This is complete graph. Okay, now we'll look at what is spanning tree. spanning tree, it should be a tree. First of all, tree means what? A cyclic graph. Tree has n vertices, means it should have n minus 1 edges. So that is tree property. But it is spanning tree. It is a special type of tree. It is subgraph of graph, means it spanning tree generates from a graph. So spanning tree is a connected undirected graph with no cycle. It is a spanning tree of a graph G if it spans G, means what? It spans start vertex to end vertices connecting with the only single edge. This is generated for this graph, subgraph. But here question is total number of spanning tree for a given for complete graph. How many spanning tree generates? This is a complete graph. How many spanning tree it generates? For example, it starts here. This go on in this one spanning tree. Here starts here and go to here and come to here, come, and this is one more spanning tree. Like this, how many spanning tree it generates? That is n raised to n minus 2 spanning tree it generates actually if it is a complete graph. But is it holds good for all other graphs, means Peterson graph or so a regular graph? No, only it holds, this formula is holds good for only complete graph. For all other graphs, still it is an open problem. You take any graph, there is no standard formula, still it is an open problem. So for this question, for a complete graph with n vertices, the total number of spanning trees is given by n raised to n minus 2 spanning tree it generates. So answer is C. I hope it's you cleared now your doubts. Now the preposition P implies Q and negation of Q or P is equivalent to the given form. Then what is the equivalent, logical equivalent? Q implies P, or P implies Q, or Q implies P, or P implies Q, P implies Q, and Q implies P. I hope it's looking at you can get easily, because it's a standard formula. Implication law. What is implication law? Actually, P implies Q is negation of P or Q. This is a standard formula. P implies Q is negation of P or Q. This is implication law. Now the given is negation of P or Q. This is negation of P or Q. You may write Q implies P. Now look at P implies Q and Q implies P. That is answer is D. Without spend more time, you can answer if you know the laws, all the laws. And so please list out all the laws of logic and laws of inferences. So list out all. You can answer such questions in 10 seconds or 30 seconds. So hence the answer is D. Okay. Now go to the fourth question. The logic of pumping lemma is a good example of. It's a straightforward question actually. This is pumping lemma theorem. A pigeonhole principle is a nothing more than one obvious remark, means where it is useful. It is very popular theorem and example in computer science. If we have less pigeonholes than pigeons and you put every pigeon in a pigeonhole, then there must be result at least one pigeonhole with more than one pigeon. So for means if we have n pigeonholes, there are n plus 1 pigeons, then at least one hole should contain 2 pigeons. This is the famous theorem. But where it is useful, how it is useful in computer science, or why you are studying this one? In the theory of formal languages, in computability theory, a pumping lemma or pumping argument states that for a particular language to be member of a language class, any sufficiently long string in the language consists a section or sections. For example, in computability theory or formal languages, it may be contain long string that contains some sections or subsections. In that, sometime you that can be removed or repeated by any number of times, with the resulting string remains in that language. That's why the proof of this lemma typically required counting arguments such as the pigeonhole principle. So to handle a long string, sometimes same string repeats, same section repeats. In that time you may use counting arguments and try to solve using pigeonhole principle. That's why hence logic of pumping lemma is good example of pigeonhole principle. The answer is for this question A. Next question is, let A is equal to x, x takes value from -1 to +1 is equal to b. The function of x by 2 means x takes any value and by 2. Is this function is injective means one-to-one function, surjective means onto function, or both one-to-one and onto means bijective function, or neither nor. But before looking this one, you should know the what is injective function. Means every member of A has its own unique matching member of B. Means definitely if it is a function, every member of A is associated with the member of, means no one element free in set A. But more than one element of A can have pre-image of B. But it is not possible in injective function. If it is one-to-one function, every element of A should have unique image in B. That is one-to-one function. That is injective function. Okay. Next, look at surjective. This means that every B has at least one matching of A. Means that all the element of, in first case, some elements may be free in B set, but in second case, surjective function, all the element of B should have image of A. Means there is no element free in B. Means all the element of A should have a image of B. All the elements of B should have pre-image of A. Definitely it holds because A is equal to B. Definitely for looking this one, this should be a bijective function. It holds good both one-to-one function and onto function, because A is equal to B, then it should holds both the conditions. So answer is bijective function. So both one-to-one and onto function. Okay, I hope it's clear your doubts. Like this question, please look at some basic definitions and all. Okay, next to go for question number 6. The number of ones present in the binary representation of the given some number is in decimal. Now you need to find how many ones in this decimal. It's a very popular question. This question, same question asked in 4 to 5 times previous question papers. So please be careful for this one. It's very important. Just how to solve this one. Usually we'll go for some traditional method. We'll solve this one using 3 into 512, 7 into 64, 5 into 8. And then we'll simplify. We'll get a 3753 octal number. Then we'll solve. We'll simplify. Finally we'll get a 9 ones. But it is not the right method, because you are writing one of the topmost exam in India. So please don't go for, you are not writing any descriptive type questions. You just solve this type of questions in a smart way. Here you need lot of smart work instead of hard work. Means you definitely you need hard work, but with the smart work you can, then only you can clear this type of exams. Now how to solve this one in easier way, just go through it. 3 into 512, 7 into 64, 5 into 8. This one you can represent using power of 2's. How? 3 is 2 raised to 1 plus 2 raised to 0. What is 2 raised to 1? 2. 2 raised to 0 is 1. 2 plus 1 is 3. Now what is your 512? Into 2 raised to 9. I hope it's easy way to represent. What is your 7? 7 is 4 plus 2 plus 1. 2 raised to 2 is 4. 2 raised to 1 is 2. 2 raised to 0 is 1. So 4 plus 2 plus 1 is 7. Now 64 is 2 raised to 6. Now you represent like this. I hope it's very simple. It's just represent in a power of 2. Then this multiply this one. 2 raised to 1 into 9. So base are same, add powers, that is laws of indices. 2 2 base are same, add power, 1 plus 9 10. Multiply this, 2 raised to 0, 2 raised to 9, that is 2 base is same, add power, 0 plus 1 9. Similarly multiply 2 raised to 6 into 2 raised to 2, 2 raised to 8, 2 raised to 6 into 1, 2 raised to 7, 2 raised to 0 into 6, 2 raised to 6. So this one 2 raised to 3 into 2 raised to 2, 2 raised to 5. Base are add, just add, then count, just count. Here 10th place 1, 9th place 1, 8th place 1, 7th place 1, 6th place 1, 5th place 1, 4th place is 0. Then just you write 4th place is 0 and 2nd place is 0. First place is 1, 0th place 1 place, 2nd place is 0, this one. Okay, then count number of ones, 1 2 3 4 5 6 7 8 9, 9 ones. So the number of ones present in the binary representation of this question you can solve easily using 2 to the power. Then you can solve easily, otherwise it's very hectic to multiply 3 into 5 12, 7 into 64, 5 into 8. It's very wrong method. Just to go for smart way. I hope it's very useful to you. Just if you have any queries, anything, just mail me. Please subscribe the channel, share it, please inform your friends. If you have any suggestions, any queries, just drop, please comment in YouTube comment box. Okay, just we'll go for 7th question. Which of the following expressions removes static hazard from a 2-level AND OR gate implementation of xy plus zx dash? Now this question, it's not easy to solve because you should know the first of all what is hazard, then what is static hazard, then you need to solve this one using AND OR gate. Now we'll solve one by one. What is hazard? Hazard in any system or obviously an undesirable effect caused by either a deficiency in the system or external influence, means this is called hazard. Means digital logic hazards are usually referred to in one of the 3 ways. Actually, undesirable effect caused by either deficiency in the system or external influences that creates a hazard. There are 3 types of hazard. First one is static hazard. When one input variable changes, the output changes momentarily when it should not. Means one input changes, definite means output is one input, one output is related. Okay, then similarly dynamic. A dynamic hazard is the possible of an output changes more than once as a result in a single input. Keep in mind here, in second one, single input, output will change more than once, but in static, one input, one output. Then third one is function hazard. Function hazard are non-solvable hazards which occurs when more than one input variable changes at the same time. This is non-solvable hazards which more than one input, here input more than one, and but output is same. That is the non-solvable hazard. There are 3 types of hazard: static hazard, dynamic hazard, function hazard. Okay, now come to the question. For example, the given is the static one hazard. Let us consider imperfect circuit that suffers from a delay in the physical logic element AND gates. Then given is f is equal to xy plus zx dash. Okay, then if you first look at the starting diagram, it is clear that there is no delay. If no delay were to occur, then the circuit would function normally. However, since this is not perfect circuit, an error occurs in the input. Means what? X, Y, Z, X dash will occurs an error 11011. How it will represent, I will show it in below diagram. And X changes the state. Now we know roughly how to hazard is occurring. For a clearing picture of the solution and how to solve this problem, we look at this is given 1 and 1 1, this is, and 0 and 1 1, this one. But where it is hazard will occur, this is static hazard. This red block is shows the static. This K-map shows circuit. The two gates are shown by solid rings, and hazard can be seen under the dashed ring. This one dashed ring. The theory of proving Huffman tells us that by adding redundant loop YZ, this is YZ, adding this one, this is redundant loop, actually this is, okay, YZ, eliminate the hazard. So resulting logic of the figure is this one, this is YZ. So so add this one YZ for, so original function xy plus zx dash plus yz. If you added yz, you can come out the static hazard. So answer is C. Just go through your previous question. This is given question is this one. If you xy plus zx dash, if you how to overcome static hazard, how to remove the static hazard, that is adding yz. So I hope it's clear your doubts now, but you need lot of practice. Okay, now come to the 8th question. Which of the following logic has maximum fan out? It's a definite question in almost all. Just look at this, is question number 8, June 2005. Same question asked. This is repeats next year. So maximum fan out is CMOS. I have explained in detail in June 2005 question part 1 video. So please go through it. Who are new visitors, already who have seen my videos, he can answer easily, but who are a new visitor, just go for June 2005 and part 1, you will get question number 8, same question you will get. But anyhow, I have listed 1 second. Important properties of logic gates, HCL means high threshold logic. I have listed all, already explained in last videos. Please go through it. June 2005 question number 8 part 1 video. Okay, next move to the next one. In a weighted code with weight 642-3, the decimal 5 represented by, now they have given some weights, and in this weight, if you use this output, which number will get a decimal 5? Just will, it's very simple. If you know how to solve this one, just go through it. A given weights are 642-3. Take it first input, first option 0 1 0 1 can be calculated. 0 into 6, just multiply binary number into weights. 1 into 4, 0 into 2, 1 into -3. Just this one multiply with the weight, then you will get the answer is 4 minus 3 is 1, but the decimal 5 is represented, so answer is not. Just go for, I will select next one, third one. Weights are given 0 1 0 1, option C I will select and check it. 1 into 6, 0 into 4, 2 into 1, 1 into -3. So 1 into 6 6, this is 0, 2 into 1 2, -3 into 1 -3. So 6 plus 2 is 8, -3 is 5. So the answer is C. You may check it B and D also, but while selecting the options, be careful. So answer is C. Up to how many variables can the Karnaugh be used? How many variables can represent in a K-map? This is very popularly you have used in digital computer organization and architecture. Actually, for this one, the Karnaugh provides a simple and straightforward method to minimize the Boolean expressions. With the Karnaugh Boolean expression having up to 4 variables. Actually, you may use 2 variable Karnaugh K-map and 3 variable, or it may be 4 variable. Sometime it may use 6 variable, but for this question you use 4 variable. So answer is B. If you want more about this K-map, just go through this link. Okay, so answer is B. I hope you enjoyed for my videos. If you really like, just like it. If you dislike it, subscribe. Please share the videos. Thanks for watching.